In this session, we are going to discuss about the column store database. So, database is nothing but what? A collection of tables. So, right, collection of data is called as a, wait a minute, collection of the information is nothing but a database. So, here in the database, first we need to know about column. We have the traditional database is relational database management system, that we call it as a RDBMS. So in RDBMS, what we do, we write serial number of the student, name of the student, say age of the student, say phone number of the students. So everything we represent in the form of columns and rows. So this is the traditional database model in which all are treated as tables, and in the table these are called as attributes. So which name antam? Attributes antam. These three rows are called as rows. So names ni attributes antam, వీటిని rows antam. But whereas in column store database, everything to be treated as columns. So in this RDBMS, it will be concentrated on rows. That means in order to identify each and every row uniquely, we are making the use of primary key. That is 1, 2, 3 should be unique. So if I write again 1 here, I need to get an error. Why? Because already one row is there. If you are writing again one row, that means a row with same number, it will show you an error message. Why? Because for this student number, we are putting a primary key. That means this RDBMS is concentrated on row identifications only, whereas this column store database concentrates on the column values. Okay, so this is a major difference between normal DBMS and column store database. So first we'll discuss what is mean by it. Column store database is a type of database that stores the data using column oriented model, whereas in this RDBMS, this is a row oriented model. But whereas this column store database, column oriented model will be there to store the data. And it can also be called as column database, column family database, column oriented database, wide column store database, wide column store, columnar database, columnar store. So all these are the different kinds of names for the column database, right? Now the structure of the column database, what will be there in the column structure? Whereas in the RDBMS, the structure is what? It is like a table. In the RDBMS, it is like a table. It have rows and columns, and the column names are called as attributes. But whereas this column store database is a concept called Keyspace. Okay, అక్కడ మనం టేబుల్ అంటున్నాం కదా, ఇక్కడ ఏమనాలి? Keyspace అనాలి. A keyspace is a kind of schema. Schema in the sense diagram in the relational model. The keyspace contains all the column families, kind of like tables in the relational model. So which contain rows, which contain column. సో ఇక్కడ ఎక్స్ప్లెయిన్ చేసినట్టుగా RDBMS లో ఏముంటాయి? రోస్ అండ్ కాలమ్స్ ఉంటాయి, మనం టేబుల్స్ అంటాం. దీన్ని ఏమనాలి? స్కీమా అనాలి. వాట్ వి కాల్ ఇట్ యాజ్ ఏ schema diagram. Rows and columns, one table is having relation with other table. That diagram is called as, consider student and faculty. So student faculty relation is there. Many students takes the information from many faculties. So that you are explaining that with a diagram. The diagram in the sense schema. Whereas in column store database, we call it as what? Keyspace. So now I'm showing you in the diagram, this we call it as what? This is a key space. So if it is of row oriented, see, if it is of row oriented, it has ID, name, grade, GPA. All these four are the attributes. What we call? These four are the attributes. These three are called as rows. That means for the three rows, for the different rows, we have what? Only one attribute row we have. So this is row oriented. Whereas in column oriented, this ID will be given as a primary key to identify each name, each grade, each GPA with a column. See here, for the name, one ID, for the grade, an ID, for the GPA, ID. That means for every attribute is defined along with the column name, which is used to identify the rows of the particular column. So this is what, this is a column family 1, this is a column family 2, this is a column family 3. So this table is a RDBMS table. I'm designing this into column oriented table of 3 column families, right? Did you understand the difference between row oriented and column oriented? Okay. Next, see here, Keyspace. As we have discussed here, Keyspace. What is meant by Keyspace? Keyspace is nothing but a diagram. In the relational model, we call it as a schema, whereas in column model, we call it as a Keyspace. See here, column family 1, column family 2, column family 3, column family 4, column family 5. But each column family may be same, may not be same. In this also, see here, in this column family, what you have here, name and ID you have. In this column family, grade, ID you have. In this column family, GPA and ID you have. That means every column family is different from other column family in the same key space. See here, I have an example. Here, user profile. What is this? This is key space. What is this? This is a key space. In this, Bob, Brittany, Tori. These 3 are the different persons of the column. So here, what you are writing? Email address, gender, age. So in this Bob family, in this Bob column family, what number of columns you have? Email address you have, gender you have, age you have. But Brittany column family, we have only email ID and gender. There is no age here, right? That means the column families may be different from other column family members in the same key space. Next, look at here, Tori. Here we have column family of email address, and country we have, hair color we have. So this country, hair color are not here and not here. That means this Tori has different column family. So column database is nothing but what? Collection of column families. Each column family may be differentiated. Is it clear? Right. Next, a column family consists of multiple rows. Each row can contain different number of columns to other rows, and columns does not have to match the columns in the other rows. Each column is contained to its row. It does not span all rows like a relational model. Each column contains a name or a value pair along with the timestamp. Note that this example uses Unix epoch time for the timestamp. So what is meant by this timestamp? See, in column family, first we call it as a row key. Okay, so row key, in previous example, look here, email address is 1 row, 1 column, gender is 1 column, age is 1 column. This Bob is what? This Bob is row key. This Bob is what? Row key. See, this row key you have. So every column has name, value, timestamp. Timestamp is nothing but at what amount of time you are inserting a row into the table. Now the time is 4:20. Consider at the 4:20, I'm inserting this column. At 4:21 second, I'm inserting this column. At 4:21 second, 22 milliseconds, I'm inserting this column. That means at what time you are inserting this particular column into the database is given as time stamp. So each column contains what? It contains one name, it contains one value, it contains timestamp. So here in this example, this is column name, this is the value of the column, this is the timestamp of the column. This is called as what? Column structure. So what is that? It is a column structure. See here, column family contains multiple rows. Column is contained to its row. It does not span all rows like DBMS. So whereas in DBMS, what will happen? Already we have discussed every time we are discussing RDBMS. So every column will have same number of rows and same data will be there in the RDBMS. Whereas in column store, it will not be like that. It should have a name, it should have a value along with the timestamp. Clear? Next, we have row key, column, name, value, timestamp. Row key is nothing but each row has a unique key, which is a unique identifier for that row. So whatever the row key you are specifying here, that should be unique. First row is 1, second row is 2, third row is 3. Like that you need to define row values. Otherwise I'll give you 1 here, again also I'll give 1 here, again also I'll give 1 here. That will not be the same. Why? Because this row is different, this row is different. But in order to identify each and every row, we need to give row key as different only. Consider in our college we have student hall ticket number. Student hall ticket number is different for everyone. Why? Because in order to identify two names, for example, Anand is there. 3, 4 Anands are there in the same class. So how you identify them? By using the hall ticket numbers only. That means hall ticket numbers are the keys, row keys to identify each and every candidate in the class. Similarly, in this column family, how many number of row keys you have, there that must be unique. That should not be repeated. Next column. In column, what you have? Name you have, value you have, timestamp you have. Timestamp is nothing but I already told you date and time of that was inserted. Some DBMS expand on the column family concept to provide the extra functionality and storage ability. So this column family database is also different kinds of we have. So that in that the most important and everybody using is Cassandra has a concept of composite families which allow you to nest the objects inside of a column. In that means in one column you may write another column. That facility is available only in Cassandra. We have different types of column families, but very most important one is Cassandra. As per your syllabus, this Cassandra is explained in your book. See here. What are the different benefits of the column database compared to RDBMS? Column stores excellent compression, therefore an efficient terms of storage, right? So as per your requirement, you can store the columns. In one column, you can store one row. In another column, you can store only one row. In another column, you can store like this row can be divided like this. That means one part of the thing is as RDBMS, one part of the thing is like a column database. Since the majority of the information to be stored in column, aggregation queries are quite fast. Aggregation is nothing but what? For example, all student marks are here, right? Marks of a student is here. Marks, different marks are there. Now I want to find out total. Now finding this total is easy by adding all these values here. Wait a minute. So here aggregation is nothing but finding all total marks. Here is easy in the column value database. Next, scalability. Scalability is nothing but column value is expanded nearly infinitely and often spread across the large clusters of machines and massive parallel processing. For example, if I want to find SEM 1 marks, SEM 2 marks, SEM 3 marks of different subjects. So different subjects are there. So I can find out computers marks, math marks, physics marks, chemistry marks individually total findings. Why? Because here in the column value database, every row is differentiated with its columns. So additions, aggregations we can perform very easily in the column value database. Load times are similarly excellent as you can easily load a billions of row table in few seconds. As you perform with the row table, you can perform the same operations with the column table also. So large amounts of flexibility as the columns do not necessarily have to look off each other. So each and every column is separately assumed. So one column is not have link with another column, like we have functional dependencies in the RDBMS, but there is no functional dependencies in the column value databases. Overall, column value database are great for analytics and reporting. So I want to find out how many marks an average data science students got in computers, and on average how much data marks they are got in statistics. If you want to find some like analytics on marks or any aggregates or anything, the column value database is very easy. And some drawbacks also there. What the drawbacks is there? First drawback is each and every value key row is having different columns. So if you have thousands of columns, right? So these 1,000 columns to be differentiated in the memory different locations. So handling them is very difficult. And designing an index schema is very difficult in this. And while this may not be an issue for some users, incremental data loading is suboptimal and should be avoided if possible. If any increments you want to do, for example, first column 50 marks are there. In next column, if you want to add 50 plus 2. But these two columns nowhere related in the column database, so that increments are not possible in this. And online transaction processing applications are also not compatible with column value databases. And next we'll discuss about the suitable use cases. So suitable use cases are many number of suitable use cases we have for this. First one is event login. So event login, for example, consider for example, you are filling an application form, right? You are filling a application form. See here, their ability to store any data structures are a great choice to store the event information such as application state or errors encountered by the application. Now I am using Zoom app, right? What app you are using to take the classes? Zoom app you are using. So how much time amount is there for that? Minimum basic is 40 minutes. Okay. So you are logging in and you are using 40 minutes and you are closing. So how your Zoom is able to tell more 10 minutes is there to close this app? So that is because of the column value database. So all applications can write their events to Cassandra with their own columns and row key of the form, application name and the timestamp. So we can scale writes. Cassandra would work ideally for the event login system. We have different kinds of column databases. Cassandra will be helpful for the event logging use case. Next, content management. No, everybody know blogging. So blogging platforms using column families, you can store blog entries with the tags, categories, links, trackbacks in different columns. Comments can be either stored in the same row or moved to be a different key space. Similarly, blog users and actual blogs can put into the different column families. And counters. So counters are nothing but, for example, if you go for visiting a web page, so there count will be there. So if I see the first time web page, the count will be 1. If another sees the same web page, the count will be 2. If another person sees the same web page, the count will be 3. So that means how many number of users are there visiting that web page, the count will be incremented. So that you can perform with the column family database. So in order to create a column family database in Cassandra, we have different kinds of syntaxes. So create column family visit counter. So already visit counter is a value column name in the column family with the default validation class. So by default the first one on 0 set cheyali, and key validation class and comparator class. So all these are the different types of keys in the Cassandra. Once a column family is created, you can have a arbitrary columns for each page visited within the web application for every user. INCR is nothing but increment visit counter by 1. Increment visit counter by 1. Increment visit counter by 1. So that may be home page, that may be products page, that may be contact us page. If you want to increment counters using SQL, we'll write update visit counter set home is equals to home plus 1, where K is M flower. So M flower is key row. We discuss the key row and column family. So this column family first create chesam kada, deentlo M flower anedi row, home, products, contact us అనేవి columns. So వాటిలో ఉన్న values ని ఒక్కొక్కదాన్ని ఇంక్రిమెంట్ చేయమని చెప్పాను by using a keyword called INCR. If you want to update it, how you do? update is a command, visit counter is a family, set home is equals to home plus 1. Home లో ప్రీవియస్ ఒక 10 మెంబర్స్ విజిట్ చేశారు అనుకోండి హోమ్ పేజ్ ని. ఇప్పుడు ఏం చేస్తున్నాం మనం దాన్ని +1 చేస్తున్నాం అంటే 11 చేసి పెడుతున్నాం. ఇక్కడ వేర్ కీస్ ఎం ఫ్లవర్ అనే రోలో హోమ్ వాల్యూని ఇంక్రిమెంట్ చేసి 1 పెంచేశాను. So, expiring usage, you may provide demo access to users, or you may want to show banners on a website for a specific time. If you watch any YouTube videos or any web pages, at the side, you may get advertisements, right? So, that advertisements also you can do with the help of the column family. In the column family, Cassandra allows time to live. How much amount of time this advertisement to be displayed on a web page? That can also be do with the help of the column family. So in order to set that, see, set customer m flower demo access allowed with TTL. So this amount of milliseconds m flower row demo access is a column name that is to be allowed. Okay, so if this time expires, that advertisement will be goes back. If you want to try a session of any game, for example, in games, in malls, we have a free demo of a game. So that demo game will be available for only 2 to 3 minutes only. It will not go for 10 minutes. Why? Because if that goes for 10 minutes, the business will be lost over there. So how much amount of time will be given for a demo? Some 2 to 3 minutes. So how you can implement that software into the demo of a game? By using this Cassandra database. When not to use. So when we are not going to use this Cassandra. So Cassandra eppudu helpful avadu ante, if you have a problem with related to acid properties, atomicity, consistency, isolation, and durability. If you want to understand this complete acid properties, please watch my videos of acid properties in RDBMS. I have a plenty of videos for RDBMS. So go through that, what is mean by acid properties. So if you want to have a control on the transactions which satisfying the acid properties, so that may not be suitable for the column family database. In there, what we perform sum and aggregate functions. So the Cassandra is not helpful for to performing summing and average. Cassandra is not great for early prototypes and initial tech spikes. During the early stages, we are not sure how the query patterns may change. As the query patterns change, we have to change the column family design. That means what? Already the architecture is designing a building. After starting construction, if you are changing the designing, what will happen? The building may not construct in a proper manner. Similarly, in the Cassandra also, if the Keyspace is designed perfectly, then only the Cassandra is helpful. If the Keyspace you are not designing well, right? Keyspace, if you are not designing well, this Cassandra will leads to many more number of problems. So wherever it may be, if your planning is right, if your planning is right, then you may get good results. If your planning is not right, you may not get good results. If architecture is designing the building plan very properly, so that the construction done properly. If the design is not correct, construction also not correct. In the same manner, in the Cassandra also, if the Keyspace is designed, queries are designed properly, then only it will be easy. After designing everything, if your query is changing, if the query is nothing but question, if you're asking the which question, which data you want, that pattern is changed, then it may not be easy to access in the Cassandra. So this causes the friction for the product innovation team and slows down the developer productivity. RDBMS impose high cost on the schema change, which is trade-off for a low cost of query change in Cassandra. Cost may be higher for query changes as compared to schema change. So in RDBMS, high cost will be there for schema change, which is trade-off for the low cost of query change. That means in RDBMS, schema change makes more amount, but for the query change is not takes much amount. But whereas in Cassandra, cost may be higher for query change as compared to schema change. Did you understand this one? Right.